Okay, so imagine this. You're on vacation. It's somewhere tropical, maybe Southeast Asia, maybe South America. The air it's thick, it's humid, and you've been walking for hours. You're sweating, you're tired, and then you see it. A street vendor selling ice cream. It looks incredible. It's frozen, it's refreshing, and you think, it's ice cream, it's below freezing. The bacteria can't survive that, right? It's basically sterile. So you buy a scoop, tastes amazing, cools you down instantly. But then, maybe 3 weeks later, long after you're back at your desk, checking emails, totally forgetting about the humidity, you get hit with a fever that feels like a freight train. A headache that will not go away, and you start wondering, was it the ice cream? Was it the tap water I used to brush my teeth? Or was it just, bad luck?
Today on The Deep Dive, we're not guessing. We are digging into a massive, systematic review, real epidemiological detective work covering millions of people to find out what actually makes you sick and what keeps you safe. And to help us navigate this, I'm joined by a true expert in the field.
He's a chartered biologist of the UK Royal Society of Biology and a senior lecturer at Tun Hussein on University of Malaysia, or UTHM. Technologist Dr. Rama Yusvana, welcome.
Thank you. It's a real pleasure to be here. And that scenario you just painted, that is the classic traveler's nightmare.
It is the nightmare. But for about, 10.9 million people a year, it's not just a vacation story, is it?
No, unfortunately not. We're looking at a global burden of nearly 11 million cases of typhoid fever annually. That results in over 116,000 deaths. It's a massive issue, primarily in low and middle income countries. But because our world is so interconnected, these pathogens, they don't stay put. They travel just as much as we do.
That number, 11 million, is just staggering. So we have this review. It looked at 22 different case control studies to pinpoint exactly how people are catching this. But before we get to the how, we need to understand the what. What exactly is the enemy here?
The enemy is a bacterium called Salmonella typhi. But there's a very specific twist with this one. Unlike a lot of other diseases we talk about, humans are the only reservoir.
So it doesn't live in animals.
Yeah.
If I'm on a farm, the cows aren't spreading typhoid.
No. It's strictly a human problem. It doesn't jump from livestock to us. It's transmitted through the ingestion of food or water that has been contaminated with fecal matter from an infected person.
Okay, so to put it bluntly, if you get typhoid, it's because you ingested particles from another human.
Precisely. It's an uncomfortable truth, but that is the reality of fecal oral transmission.
That is vivid, but helpful for understanding what's at stake. So how do we track this? In the study, you use a framework called the F diagram. Sounds technical, but it's actually a really clear way to visualize the danger zones. Can you walk us through that?
Of course. It's a classic tool in public health. The Fs represent the different rides the bacteria takes to get to you. So we have fluids, fields, fingers, food, and flies.
The 5 Fs. Okay, let's break those down.
Right, so fluids is water. Fields refers to the environment, so soil, floors, open spaces where waste might accumulate.
Got it.
Fingers is essentially hygiene and hand contact. Food is self-explanatory. And flies, well, they act as what we call a mechanical vector.
A mechanical vector, what does that mean?
Think of a fly as a microscopic taxi service.
Oh, great.
It lands on waste in the field, picks up the bacteria on its legs, flies into your kitchen, and lands on your food. It physically taxis the pathogen from the waste to your dinner plate.
That is a terrifying mental image. A taxi service for bacteria?
It is, but it's effective for understanding the risk. Now, the study we're looking at today used a case control methodology to look at these routes. Essentially, it's a backward investigation. You take a group of people who are sick, we call them the cases, and a group of their neighbors who are healthy, the controls, and you compare their lives.
So you're looking for the differences. Like, did the sick person eat at the street stall while the healthy neighbor cooked at home?
Exactly. And we measure that difference with a metric called the odds ratio. We don't need to get bogged down in the math, but the concept is simple. If the number is 1, there's no difference. If it's greater than 1, say 2.0, it means that behavior doubles your risk. It's a risk factor.
And if it's less than 1?
Then it's a protective factor. It means doing that thing actually lowers your chances of getting sick.
Okay, I like that. It's like a scorecard for safety. So let's go through the F diagram using the scorecard. Let's start with fluids water. I think for most of us, especially in developed nations, there's an assumption if water comes out of a pipe, it's safe. Does the data back that up?
This is where we see the first major crack in that assumption. The data draws a very sharp line between having an improved water source, like a piped connection, and actually treating that water.
So the pipe isn't enough?
Not necessarily, no. The study found that having an improved water source does help. It reduces your risk by about 27%. The odds ratio is around 0.73, which isn't bad. But behaviors that involve treating the water at the point of use, so boiling it, filtering it, using chlorine, were much stronger protectors. Treating the water reduced the risk significantly more, with an odds ratio of around 0.59.
So treating it yourself is almost twice as effective as just trusting the pipe. Why is that? I mean, if the pipe is improved, why is it still risky?
It comes down to consistency and integrity. In many developing regions, water pressure isn't constant. So when the pressure drops, groundwater, which might be contaminated by sewage, can actually seep into the pipes through tiny cracks.
I see.
Or the storage tank on the roof might be open to the air. By the time that water reaches your glass, the improved source might be compromised.
So the pipe is a variable, but boiling is a constant.
Exactly. The only guarantee is the barrier you create yourself. The boiling, the filtering.
And what about the data on not doing this?
Drinking untreated water was a massive risk factor. The odds ratio there was roughly 2.4.
Wow. So you are more than twice as likely to get typhoid if you drink straight from the tap compared to someone who doesn't.
Correct.
That's a powerful takeaway. The infrastructure is the baseline, but personal behavior is the firewall.
You know, speaking of firewalls and finding ways to block these pathogens, I know we have listeners who are fascinated by this. They might be studying biology or public health, and they want to go beyond just listening. You actually have a way for them to get involved, don't you?
I do, yes. We're currently expanding our research team at UTHM. I am looking for MSc or PhD students who want to dig into herb-based medicinal alternatives to minimize the impact of these disease agents.
So looking for natural plant-based solutions to fight things like Salmonella.
Precisely. We're looking at how traditional knowledge can meet modern science.
Yeah.
The really unique thing about this program is that the data collection and analysis can be conducted right in your home country or your own research institution.
That is a fantastic opportunity. Global research from a local base. We'll remind everyone about that later. But let's get back to the F diagram. We've covered fluids. Now what about sanitation? The fields.
This is where the study threw us a bit of a curveball.
I was reading the notes on this and I had to double check. The common sense logic is, typhoid comes from waste. Therefore, toilets should be the ultimate solution. If everyone has a latrine, typhoid disappears.
That is the logical assumption. But in this specific meta-analysis, they found that household latrine availability and, surprisingly, even open defecation were not significantly associated with typhoid risk in a statistical sense.
Wait, hold on. I need you to explain that. How can open defecation, going to the bathroom outside, not be a huge risk factor? That seems to defy gravity.
It does seem counterintuitive, but we have to look at the specific biology of typhoid versus something like, say, cholera. Cholera has an environmental reservoir. It can live in water and soil for a long time. Typhoid lives in people. So just having a toilet structure doesn't automatically stop the transmission if the hygiene behavior isn't there.
I see. So you can build a gold-plated toilet, but if the person using it doesn't wash their hands, they're still walking out of that room as a carrier.
Precisely. The structure alone isn't a magic bullet. The bacteria doesn't care if it was deposited in a ceramic bowl or a field, if it eventually makes its way to your food via your hands.
Right.
However, there was one sanitation factor that was highly significant: unsafe waste management.
Okay, so distinguish that for me. What's the difference between latrine availability and waste management?
Waste management is the systemic level. We're talking about burst sewer pipes, waste leaking into the street, or latrine buckets being dumped into nearby streams. That increased the risk by about 56%, an odds ratio of 1.56.
So it's about containment failure. If the whole system fails and the waste escapes, it doesn't matter if you have a toilet in your house.
Exactly. When the environment's overwhelmed with waste, when the fields are flooded with it, individual household toilets can't protect you.
So if the toilet isn't the shield we thought it was, surely this brings us to fingers.
This is the most crucial part of the findings. The fingers component, hygiene, was the strongest and most consistent finding in the entire review.
Stronger than water, stronger than waste management.
Yes. The data showed that good hygiene, and specifically hand washing with soap, had an odds ratio of 0.52.
So it basically cuts your risk in half.
Almost exactly half. It's incredibly powerful. And on the other hand, a lack of hygiene had an odds ratio of 2.2.
So not washing your hands more than doubles your chance of getting sick.
Correct. And this really explains the latrine data we just discussed. A latrine prevents the field's contamination, but it doesn't stop the finger's transmission. If you use a latrine but don't wash your hands, you are essentially bridging that gap for the bacteria yourself. You become the vector.
It's the invisible carrier. You know, it is somewhat humbling. We look for these high-tech vaccines and massive infrastructure projects, and they are important, but the data says one of the most effective tools we have is a bar of soap.
It is the simplest intervention, but often the hardest to implement consistently because it requires behavioral change. It's something you have to do every single time. It only takes one slip-up.
So true. Okay, just a quick micro recap here. We know pipes aren't a guarantee. You need to treat the water. We know toilets aren't a guarantee. You need to manage the waste system. And we know that hands are the bridge that connects it all.
That's a perfect summary.
So let's talk about the one that hits close to home for anyone who loves to travel, food.
Yes, the food route.
I started this dreaming about an ice cream cone. But broadly speaking, is eating out dangerous? What does the data say about street food?
The data is quite clear on this. Eating or drinking outside the home was a significant risk factor. The odds ratio was 1.62.
So you're about 60% more likely to catch typhoid if you eat out versus cooking at home. Why? Is it just that street vendors are dirty? That feels a bit like a stereotype.
It's not about them being dirty. It's about the loss of control. When you cook at home, you control the washing, the cooking temperature, the hand hygiene. When you eat out, you're outsourcing that safety to someone else. And remember, typhoid comes from a human carrier. If that food handler is shedding the bacteria and they don't wash their hands...
So it's on your plate.
Exactly. You're trusting their hygiene with your health.
Okay, let's get specific. I'm still holding on to hope for my imaginary ice cream cone. What specific foods were the villains?
I'm afraid I have some bad news for your ice cream.
Oh no, don't tell me.
Ice cream was identified as highly risky with an odds ratio of 1.49.
See, this is the part I don't get. I thought freezing stopped bacteria. Doesn't the cold kill them?
That is a very, very common misconception. Freezing stops bacteria from multiplying. It puts them to sleep, essentially, but it does not kill them. In fact, freezing is a great way to preserve bacteria. Laboratories freeze bacteria to keep them alive for years.
Wait, so my freezer is basically a cryogenic chamber for Salmonella?
In a way, yes. Salmonella typhi can survive happily in frozen ice cream for a long time. So if the milk or the water used to make it was contaminated, the freezing process just locks that pathogen in a state of suspended animation until it hits your warm stomach.
That is horrifying. So the cold actually protects the bacteria until I eat it.
Exactly.
Well, there goes my summer treat. What about other foods?
Dairy products in general were high risk, likely for similar reasons. Lack of pasteurization, maybe. Fruit juice was another big one.
Because it's raw.
Yes, and often diluted with untreated water or served with contaminated ice.
It's always the ice.
It often is, yes. But here's the interesting surprise in the data. Vegetables and fish, or shellfish, were generally not significantly associated with risk in the overall analysis.
Really? I would have thought shellfish would be incredibly risky. Don't they live in the water where the waste goes?
They do, and for something like cholera, yes, shellfish are a huge risk. But for typhoid, the lack of association likely comes down to how we eat them. We usually cook fish, we usually cook vegetables, or at least wash and peel them.
And heat kills typhoid.
Heat is your best friend. Thorough cooking kills the bacteria very effectively. That's likely why those categories didn't show up as major risks in the same way that raw or frozen foods did.
So if I'm hearing you correctly, the old rule of thumb for the traveler or for anyone in an endemic area is basically cook it, peel it, boil it, or forget it.
That old adage holds up remarkably well against the data. If it's steaming hot, the risk is low. If it's cold, raw, or frozen, beware.
It is amazing how the data tells such a clear story when you put it all together. It's not just random bad luck, there are patterns. So let's take a step back. If you had to summarize the big picture for our listeners, what's the headline here?
The headline is that preventing typhoid is heavily dependent on household and individual behavior.
More than infrastructure.
Infrastructure provides the baseline, but the data really shows that human behavior is the deciding factor.
Let's break that down to some final takeaways.
First, water. Just because it comes from a pipe doesn't mean it's safe. The barrier of treatment, boiling, or filtering is critical. Don't trust the source, trust the treatment.
Check. Treat your water.
Second, sanitation. Toilets are important, but for typhoid specifically, they don't stop transmission unless they're paired with hygiene.
Check. A toilet without soap is just a seat.
Exactly. Which leads to the third and most important point. Hand washing with soap is the single most powerful tool we have. It halves the risk.
And finally, food.
Be very careful with cold foods prepared by others. Ice cream, juices, raw dairy. These are high risk because they bypass the protective power of heat. If you're eating street food, choose something coming right off the grill or out of the wok.
That is such actionable advice. It's really empowering to know that these simple actions are backed by millions of data points.
It is, and it brings us back to that unique nature of typhoid we started with. It's a human parasite. It relies on us to survive and spread.
Which means it relies on our mistakes.
Exactly. But that also means it relies on us to stop it. If we change our behavior, we can break the chain completely.
That is a really provocative thought to end on. We are the reservoir, so we are the problem. But that also means we are the solution.
Precisely.
This has been absolutely fascinating. Thank you so much for breaking this all down for us.
It has been my pleasure. Thank you for having me.
Before we go, I just want to remind everyone about that incredible opportunity we mentioned earlier. If you found this fascinating and you want to be part of the solution, Dr. Rama Yusufana is looking for MSc and PhD students to join his research team at UTHM.
Yes, we are diving deep into herb-based medicinal alternatives to fight these agents. It's vital work, and remember, you can conduct the data collection and analysis right from your home country or institution.
A truly global research opportunity. And for those of you listening, we have a question for you. Think about your local street food culture. Does it prioritize hot, cooked meals, or are cold treats more common? After hearing this, how might that change your risk perception? Let us know.
I would be very curious to hear those answers.
We want to express our utmost gratitude to technologist Dr. Rama Yusufana for his time and his invaluable insights. It has been a real eye-opener.
Thank you. Stay safe and stay curious.
For a summary of everything we discussed, check out the link in the description. Thanks for listening to The Deep Dive, and we'll catch you in the next one.